Guys, in this video, we're going to go over the general formula for the area of any triangle. Okay, so in the do now here, we have a diagram um, of it's not a a right triangle because it's the height is not vertical like as is triangle ACB. We don't have a vertical height, but we're going to see how we can get the formula for the triangle. So it says label the altitude drawn from point C to the x-axis as h. So it's talking about this kind of lighter line here. So we're going to call that h. And because it's an altitude, we know that this is now going to form a right angle like this. What is sine of theta in terms of line segments in the picture above? So remember, sine of theta is equal to opposite over the hypotenuse. So for this triangle here, sine of theta is going to be equal to the opposite side is h over b. Okay. What is the height of this triangle in terms of sine theta and b? So we're basically trying to solve for h. So from this problem here, we would just multiply both sides through times b. So you have h is equal to b times sine of theta. Okay. So what do we know about the area of a triangle? We know from all the way back in like elementary school that the area of a triangle is half times base times height. So what we can do here, the base in this problem is C. Let me zoom in actually. Let's just go back and forth. And then the height in this problem, we just found h was b times sine theta. So that h in the problem here is going to be replaced with b times sine theta. Okay. So what we can, the more general formula, the way you'll see it written for any triangle is area of a triangle is equal to 1/2 b times c times sine of theta. So if we look at the way it is here, b and c are side lengths of the triangle, and then theta is an angle. So specifically, b and c have to be adjacent sides. B and C are adjacent sides, and then theta is the angle, is the included angle. Okay. Has to be between the two sides. So it's like if we go back to geometry, right? It's side angle side, right? So now if we recall here for the area of a triangle, like the area of a triangle that we know, 1/2 base times height, right? Why don't we need to account for sine of theta? Take a second to think about that. So in a right triangle, why is it that we didn't have to, why does this go away? Well, if we think about the angle, right? If we have an included angle, because normally it would be, we would take the base times the height like that, right? So here's a sketch of a right triangle, right? This is how we would normally find the area, and then this would be the hypotenuse, so we wouldn't have to do anything with it. Well, if we apply this same formula, area is equal to 1/2 base, the C value is going to be height times sine of the included angle is 90. Whoa, you guys should recall, right, from the unit circle, sine of 90, that's 1. Oh, so that's where we get this general formula from. Okay. So what happens here is that this sine of 90 essentially disappears, and you're just left with the simplified form, area is equal to 1/2 base times height. So this, basically here, the formula that we've known, is just a very specific case of this more intimidating looking formula, but it's the same concept. Okay,